Hi, my name is Annika. I am a senior at Hagerty High School and I am part of the Hagerty Robotics program. I'm the 2021 team captain of the Water Dogs.
Hi, I'm Lily. I'm a senior at Hagerty High School, and I'm the sophomore lead of the Water Dogs.
Hi, my name is Ritam Rana, and I'm a junior at Hagerty High School. I'm excited to be a part of the Water Dogs this season, and I'm a programmer for the team.
Hi, I'm Samantha. I'm a rising sophomore at Hagerty High School. I am a programmer for the Water Dogs.
Hi, my name is James Hugh, and this year I'm a senior at Hagerty High School. I'm a programmer and strategist for the Water Dogs RoboBoat team.
Hi, I'm Anushka Seal. I'm in 10th grade and I am a programmer for the Water Dogs.
So our boat is styled after a catamaran, but unlike a catamaran, instead of two holes, we have three. The third one is right here in the center, and it stores our batteries. What this allows us to do is have a low center of gravity, and we had tried other designs before, but it made us sink, so this turned out to be the most optimal one. So the goal of the whole design was to increase and optimize our speed. To do this, we had to decrease drag, and luckily for us, we were donated Orca 3D, which is a naval architecture software that allowed us to design and edit specific sections of the hull in such a manner that we could decrease the drag.
The brushless motors are the same as the motors on electric skateboards and help speed up the boat. The brushless speed controllers are each attached to a prop on the back of the boat and is an open source design by Vesk. There are two rudders that are used to fine-tune the steering during long distances. The independent control of the prop allows for a tank drive approach for maneuvering in tight spaces. The cooling system has a pump that brings water from the lake to cool the boat through two radiators. On hot days, we use dry ice.
Our boat utilizes multiple sensors, including a sick LiDAR sensor used for range detection of the buoys, a Navcom GPS that uses a Starfire system to receive satellite corrections, which is used to give us accurate positioning, as well as an IMU, which has an incorporated gyro, and a GPS system which uses a Kalman filter. However, this GPS is not as accurate as the Navcom GPS system.
The primary strategy of the Water Dogs was to create a durable yet lightweight system architecture with a focus on speed and mobility, customizing our design to our chosen tasks. The main reason for choosing a catamaran design was the stability and customizability that it offered in comparison to the typical monohull design. In the previous years, the Water Dogs have focused heavily on the development of a reliable hull structure and propulsion system, with less emphasis on software experimentation throughout the season. To meet new challenges in the 2021 RoboBoat competition, specifically Find the Path and docking, we decided to try using new software in our development process. We assigned each team member an area of focus, which allowed us to accomplish our tasks quickly. Instead of rebuilding our boat, we focused our time on improving upon our catamaran design, which is much more efficient, looking back.
Using Ross Gazebo, the Water Dog's goal was to use our sensor data to its maximum potential, with the use of fine-tuned programs and the use of simulative testing. Our team has relied on ROS for many years to interface between our programs and the hardware on the boat. Using simulative testing, our team was able to work much more quickly than we did before. By running our programs in a simulation, we were able to identify and resolve small bugs and problems directly on our computers, rather than having to go through the arduous process of in-water tests. Without these tools, our boat would not be where it is today, and we gladly recommend this approach for other teams. We would assign a confidence rating of 9 out of 10, as our boat was able to effectively accomplish the tasks set out at the beginning of the season. While going through a pandemic, we found that it was difficult to work separately by assigning tasks to each person. Because of this, we started the Water Dogs Discord server, where we were able to communicate with each other via the internet. We would join certain voice channels to discuss certain aspects of the boat, such as the hull or the sick LiDAR sensor mentioned earlier. We also used robot operating systems, also known as ROS, in addition to the Robot X simulation environment, including Gazebo. This allowed us to simulate the boat on the computer as well as all of the vision and tracking software we wanted to test. This was a critical factor in determining our success, as without the software, it would have been very difficult to test our boat due to certain restrictions set by the pandemic. We previously utilized PTC Korea to design and manufacture parts, however have made the switch to PTC Onshape, which allowed us to create a compartment for the batteries. We also used Orca 3D to create the hulls, as Lily mentioned earlier, and Autodesk 123D, which allowed us to create a DXF file for our laser cutter.